Hey, hi everybody. I want to do the same thing like the other person because this venue is too nice and I'm an architect and wow, it's really nice. I want to take a little photo of all of you. I hope you don't mind. And then one with me inside of it too. Thanks for that. So, question. How many of you use Blender here or have used Blender? Oh, wow. Nice. A lot more than I thought. So my name is Dimitar Pouchnikov. He did a pretty good job with the pronunciation, by the way. So a little bit about me. I'm an architect and designer. Something like a Blender evangelist as well. I run UH Studio, which is my own tiny company. I do a lot of architecture design for small companies, some consulting, some freelance design work as well. And I'm also really passionate about how architects and designers can use Blender for parametric design, for design in general. So I do that in a couple of different ways. One is with uhstudioacademy.com, where I have courses, then I have a YouTube channel, and I like to collaborate with people quite often as well. And why can I do that? Because I've been working for something like 12 years as an architect, mostly in London, which is where my education is from as well. So what is design? I think this group is probably a little bit more technical than what I'm used to, so your idea of design might be a little bit different than my idea of a design, but for me, it's where beauty and function meet. How? And the big question, right, is how does Blender play into this? And more importantly, what is beautiful architecture? How do we even define that, right? Well, let's take a step back and how do we get to a good result? And I think this is probably universally true, right? So we experiment, we iterate, we evaluate, and then we repeat. So I always like to use this example because it's built and I think people might have some reference in it. It's in London called Drops Yard, so it's like a 10-minute walk from St. Pancras International. So the cool thing about this project is the roof, right? It's pretty darn cool. If you haven't been there, definitely go visit it next time you're in London. And so how do you get to that solution? You experiment, you iterate. These are only a few of the iterations that they've done. And then you evaluate. And then, of course, because this is architecture, we have a lot of other evaluations as well. Like how do we create the structure about this? Is it safe? Are there windows in there? And so on. But on top of that, we have to think about creating a great sense of place and identity. So this project, I'm going to walk you now through a little bit, let's say, less proceduralism, but more design. So you kind of get an insight into my world and what it takes to get to this level of architectural design. And then we're going to talk a little bit more about parametric design within Blender, procedural design. In architecture, we like fancy terms, so we call everything parametric. So this is an amphitheater, a park. It was many things. And it was a commission project. Sadly, it's not going to get built because the client ran out of money, which happens a lot. They built everything else around it, and this was the last plot. And they're like, yes, we're going to make the center of the world. We're going to put absolutely everything in it. We presented to them, and they say, they run it by their guys, and they're like, oh, we don't have money for that, but thank you. But at least I can talk about it. So what is it? It's a big plot of land between a lot of buildings that has specific programmatic requirements. So let me see. Nope. It's not working where I need it to. Anyways, so up here you can see the different paths that we need to understand on the site. And then because there's going to be event spaces, we also need to understand what kind of events are going to be happening, how often, where, and most importantly is what are the spatial requirements, because event spaces are fairly big. What's it doing now? And so we evaluated a lot of different kinds of event spaces that we wanted to include in there, thinking about, how many people we wanted to fit in, what are the different kinds of event scenarios, and we came up with this example that you see here in regards to something that works pretty well. Then thinking about it a step further is how do we create a more multi-purposeful space by creating a series of small spaces? How do they fit together so we don't only have one kind of event, but we end up having a series of different possibilities into there? So that's the work, and this is of course only a fraction of the work that's needed to get to the next level. And you might confuse this image here as being architecture, which is not. This is the program that drives how we then address the architecture. It's more like the technical requirements that we need to have onto there, and then we start to have fun. So what sorts of fun? Well, Blender fun, of course, what else? So in here, I'm showing 3 of the options that we sort of considered near the end of how we're going to address this sort of architecturally. And I'm going to talk about it and I'll start showing a little bit of Blender as well. So the first one is called fracture wadi. This is in the Middle East. So wadi is like a crack with natural water. And so these are some architectural visualizations. Clearly you can see the event space, and clearly you can tell that it's not a fairly complex model either, right? But that's what we need at a certain point in concept architecture and conceptual design, is having a sense of the space, understanding how it works, and does it meet the technical requirements on top of it. And then these are artist representations on top of a Blender model, which I'll show you shortly. It's terribly complicated, I know, of how to get to this. And the big red circle there is the event space that we have. So again, this is starting from a fairly, let's say, a low threshold at one point into proceduralism. I start with a plane, I subdivide my plane, and then I start to push and pull some vertices around. But hey, sometimes in design, that's what we need to do, because proceduralism for us as designers is not the end game. It's a part of the journey that helps us get to the end game faster. That's why I'm actually not afraid to speak not only about proceduralism, but how much we need it versus how much we don't need it within architectural design. Now, this is another option, which is hexagons, yes. And it starts to get a little bit more procedural. In Blender, so we have one hexagon arrayed once, then twice, then 3 times, then 4 times to get our whole grid. Pretty simple and straightforward. Then creating a lattice to sort of deform it, and then booleaning some parts out. So we're only left with the kind of geometry that we want. And then this is 4.5 years ago, so this is before geometry nodes was introduced into Blender. So I did this manually. It's a movie, hopefully it plays, yep. So what's important here is that it still addresses all the technical requirements that we set up, but we're also starting to get a sense of what the space is like. And that's where, for a designer, actually Blender is a very good medium, because not only am I designing the geometry in there, but I also have some, let's call it previous visualization. You can go all out, as you'll see in some later examples in regards to what we can do. But even having a little bit of sense of shadow and sense of materiality and being able to populate with geometry nodes people really quickly gives me a sense of scale as a designer. So I know right away whether this space works fairly well or not so well. So this is the one that we actually went ahead with. So this gets a bit more developed. So that starts with like some kind of concept, some sort of initial idea, which we call it a weave, but it's actually sand dunes, because in the Middle East, everything is sand dunes, right? So you have to have that. This reference comes a lot, but we call it a weave. And so we look at references that we think are going to be quite suitable. And the motion of sand is actually where it kind of started, and some artwork that represents that sense of motion. And quite literally, the initial diagram was that initial art that you saw being superimposed onto it. It ended up working fairly well. You can see this as a bit of a derivative from that space. So we have our event space, we have our programmatic requirements, where there's a bridge which is 6 meters ahead, so the landscape has to sort of step up, then we have to connect from like one side to the other side. So that is satisfied into here. And then this, because it does get a bit more developed, we did a series of iterations where I'll show you how this is done in a second as well, where it gets a little bit more developed, but still meets those basic programmatic functions. And the the event space functionalities as well. And that's what the space would have looked like. These are not images with Blender. They're with an external visualization company, but all the other ones after that I've actually done myself as well. I think it turned out pretty nice. Sad they didn't build it. But anyways, we have a wonderful Blender model to show you. So we start with a plane, we subdivide it, and then we get some strips. So a pretty similar logic. Of course, those strips, you know, because of subdiv, we can be quite playful with it. At some point, we have to be a little bit less procedural, or let's say break the proceduralism, even though now with geometry nodes, might be able to keep it connected to the original for a bit longer. At some point back then, we even had to bring it into Rhino in a software called Grasshopper, which is our Houdini in a way, where everything that we want with nodes based, that's what we do, to geometry nodes. I hope there's more architects that switch to that soon. And this is a little walkthrough that shows like the final model. And again, for me, for architects and designers, it's really important to have that sense of texture, sense of shadows. And you know, I didn't spend too much time with the texturing in this for Eevee, but just being able to walk around and understand like some specific spatial qualities of the space for designers is really important. I am, though, really curious to get this into Unreal, because a lot of people are doing that. If somebody knows how to do that with preserving the textures, then please talk to me after, because I tried it a couple of times with FBX and it was a nightmare. I was like, no, I'm not going to spend so much time with it. So I think I'm preaching here to the converted already, but iterating faster, right, more procedurally means better design. Hopefully, not always. You know, there's some stakeholders, they have their own ideas, maybe, so they kind of try to change the meaning a little bit of these things. And this is a different example, and I bring it up because it's kind of a niche situation, and I think if you know how to use like some procedural tools as a designer, then you try to use them all the time because frankly they're fun and they make me do my job a bit better. So this is a building that's currently in construction, and it's designed in a more, let's say, traditional way, as we architects do, which is in a program called Revit and also a program called Rhino. But the facade of this building over here was it's a bit funkier, right? It's actually a lot of fun. And so how do you do something like that? First off, you know, we have to understand the facade, the different sections, you know, what kind of area is it? Is it residential? Is it office? Is it podium? And then doing some work with it. So this is where the fun starts, right? We have the basic setup done. Again, we sort of understand the programmatic requirements, and then we know as a designer how to shift them and adjust them. So we start with the facade chunk, then subdiv, then do an array, and then array and a mirror to get something like that. The building is in construction. This photo is fairly old. I really hope they're well done by this point, but I'm not sure. This is in Lagos in Nigeria. So that's how it works in Blender, right? So we have that first chunk, mirrored, arrayed, subdivision, lattice to sort of deform things, and then curve it along the footprint of the building. Then another lattice, why not, right? And then pulling out some parts out that are not needed. So this is what I really like to talk about, even more than the complex things, because it's something that many people, especially as designers, don't realize that we can do it in a more efficient way. It doesn't need to be all nodes-based and all terribly complex, and it still allows the designer to be better at their job because you can adjust things much easier. And now we're getting a bit more procedural, a bit more parametric. So currently I live in a city called Varna, which is on the seaside in Bulgaria. And it's got beaches, but not enough beaches in the summer. And I was thinking, it would be nice to have some kind of beach pavilion in there. So I sort of designed it, and I realized then, oh, this would be actually quite good to teach people how to use parametric design. So the way it works is we have one chunk that's mirrored and then arrayed. Pretty straightforward. And that's the part, the whole, and then subdiv. And then this is another iteration, and this is where it gets really cool. What do you think the difference is between this and that? It's the same thing, in a way. And that's where parametric design starts to be really fun. Of course, now that it looks kind of in the same setting, maybe you see a bit more similarities, but let's see now here. So this is rebuilt with geometry nodes, but it's very simple what I'm doing in geometry nodes, really. And that's what I appreciate is the quick things. Of course, there is a time and place, especially in architecture, for the very detailed ones. I have some colleagues that have developed fantastic scripts, which are almost their own programs of how to panelize and rationalize complex facade systems for buildings that need to be sent with like a package this big to the manufacturer to be able to cut the pieces from their complex machinery. Anyways, back to our slightly simpler world here. So we have this, which is the chunk that goes in geometry nodes, just mirrored, and now with a few versions back, Blender introduced repeat in geometry nodes as a zone, so it makes it incredibly simple. We just repeat a rotation 60 degrees 6 times to have this whole chunk. And then if we want to, I exposed the scale in geometry nodes, which lives as a modifier in case you don't know in Blender. So we can always pull it out and have that per instance. That's why we have these buildings all looking slightly different, even though they're from the same family. And if we have good topology, then it doesn't matter how we stretch, push, or pull this. It's always going to look pretty good. And one of my favorite modifiers is called simple deform because, again, if we have good topology, it does like a global deformation of it. Of course, you have to be careful of it because based on the scale of how big your building is, if you say 25-degree rotation or 75 as I have here for something that's this tall, it will be slightly different than for something that tall. So it's not that precise per se for what we need as architects, but it's good for these initial concept design phases that we have over here. So then how does all that start to play together? Or how do we even take that even further? So that same chunk, we can tessellate it onto a mesh. So Blender has an add-on that's called tissue, but it's essentially just tessellation. It just exposes all the complex settings to a designer, so we don't need to mess with the code too much. But essentially, this is the same, right? But we have all these different parametric variations that are based on this just singular chunk. And that can work in many different ways. This is working in the exact same way. We have, let's call it a panel, a component, and then a base mesh, which is just the footprint. And anything we adjust, it starts to adjust in there. And because we can see how some faces are getting bigger, then we get this really kind of nice spiral effect. Really simple when you think about it, but the results are quite complex looking. And on a smaller scale, there's also a place for parametric design. This one is pretty straightforward. It's just a house, but it's mirrored. So I only need to work in one area, right? For you guys, the things that I've seen here, which are really complex, you're like, of course you can use procedural mirror. Why would you never know? But in the architecture world, people don't know that. And of course, stairs and everything else that could be procedural, I do it as procedural, even in a more traditional house like this, where you have the building done in any way possible, right? Because that's not the point here. The point is the design. But the chandelier is done with geometry nodes. These stairs that you see on that image over there, they're also parametric, so they can be changed. This Japanese sort of slat system as well. So there's always like little potentials for it that for me personally, I can play, with like, for example, that radius curve, which I see now on the big screen does need a bit of adjustment, but I'll leave that for myself. So then going to even more parametric level is how do we just play with form? I think that's really important for designers is understanding how space is formed around its container. Did I say that right? Are you paying attention? So I do a lot of these experiments which are, again, purely formulaic of understanding how we can really push the speed of how we can design and experiment with different kinds of workflows. So this is done with tissue add-on. Again, it's tessellation, and a couple of people have ported tessellations in geometry nodes. They just don't have all the options as the tissue add-on that I'm used to working with. So that's why I still use it. But hopefully, you know, as those get more advanced, then it'll be even faster actually with geometry nodes of how to do these kinds of forms, which again, how do they work? We have our base meshes over here. We have the component. And if we want to adjust something, now I'm going to move this vertex. And I just hit refresh over here. And then this thing adjusts. It's pretty straightforward, pretty simple, but pretty effective for designers. And a lot of people would actually try to model this manually by hand, which if you try to modify it afterwards, you basically have to rebuild it. But why do that if you can do it procedurally? And then this is kind of a city that I started doing, not a city, let's say, but like oh, I can call it a level here. It's not quite that because I actually don't know too much about Unreal, but it shows all the different kinds of techniques. So some of the twisted, smaller residential towers, they're done with tissue. So we have two components. One is for the main balconies, and one is for the side ones. And then over in that image, the big rotating twisted tower is actually done very similar to the beach pavilion, where you start with one chunk that's mirrored, and then that's arrayed. And then because it's a building, it gets a bit more complex. We have to figure out the levels from the inside, populate them with a bit to make it a bit more interesting. And again, whenever I can, I love doing like little EV walkthroughs. They're not visually the highest fidelity, but they still give enough to understand, you know, materials, even though there's no materials here, but at least trees, proportions, a sense of shadow, and so on, of how all these things start to come together. And in the background, there's some other buildings as well, which I haven't talked about, and they're using pretty similar concepts. That one, especially in the middle over there, it's a bit more complicated because it uses an attractor and the pavilion on the bottom. But everything here is still parametric. Like if I want to, we can go and move it around. So that's it for me. I do have YouTube. I'm really passionate about sharing how Blender can be used for design. And parametric design is a big part of that because, as you see, it's so easy. So I tend to post a lot of videos on there. Whenever I get a chance, recently not so much. You can check out uhstudio.com for architectural design, and I'm actually always curious of the gaming industry and the design aspect of it, and also the film industry. So if you're in those and you know about design, then come and talk to me. And there's also Studio Academy where I actually teach some of these. So thanks so much. Thank you guys for having me. Question over here.
Hi, first of all, thank you so much. Amazing presentation. As an architecture student myself, it's amazing to see you presented here. I was wondering what made you switch away from Grasshopper and the more regular workflows with Grasshopper, Rhino, Revit, towards Blender?
Great question. Yeah, so as I mentioned, you know, as architects, we have our workflows, set of workflows, and Blender is not part of that yet. I'm hoping more and more people adapt it. And Rhino and Grasshopper is something that more people use it. I do use Grasshopper a lot, and for more, let's say, developed things that I know they need to be rationalized in a specific way, I would put them in Grasshopper. But for quicker designs, I just found it's a lot more efficient and faster to do it in Blender than trying to make everything in Grasshopper. Because even as an advanced, and that probably applies to anybody, as an advanced node-based user, and I think the F1 guys, you talked about it pretty well. We always have to have this counterbalance between how long does it take to develop a tool, and essentially that's what we're doing here as well, isn't it? Is developing a tool versus the result that we get. And as I was learning Grasshopper, I was struggling so much with that question. I was like, yes, just a couple more hours to get it. And then by the time I'm done making the tool, you know, my manager comes and says, oh, actually, how about we try this? And I'm like, my God, it's 10 p.m. already. I'm not even actually started with the design, and I have to redo the whole thing again. So there's always that question. And with Blender, I just found it to be quite faster to do that.
Thank you.
Okay. Are there other questions?
There's one here in the front.
Ignoring the fact that clients may have certain stylistic ideas going into this process, are there architectural styles that are more suited for parametric design and some that are less suited for parametric design?
Absolutely, in one way. And then in another, not. When we're considering aesthetics, yes, like most of my work, I went to the AA school, which is closely affiliated with Zaha Hadid Architects. In fact, Patrick Schumacher, who's now the sole remaining principal after Zaha passed, co-founded my program there. So a lot of the people a lot of my friends do work at Zaha's office. So there's a very close affiliation, which is probably what you're seeing from some of my work, which is, again, maybe more aesthetically based. But there's a whole other field of parametric design, which is more performance-based. So that's looking into, I'll give you a simple example. I had a project that was under viaducts. You can imagine old viaducts kind of like this, but more stretched out. And they're 200 years old or so. And we had to look at like the facade underneath of it and make it. We had the information, we had the scan, and we had to make the mullions, the facades, the storefront facade, very specific to each instance. We can go ahead and do that modeling work manually, or we can just do, and I did it with Grasshopper back then, sort of sort it out based on, you know, the parameters, the height, the radius, and so on to do it.
Okay, thank you very much.
Thank you.